A solar storm is a natural phenomenon that occurs when the Sun releases a burst of magnetic energy and highly charged particles into space. When these particles reach Earth, they interact with the planet's magnetic field and atmosphere, producing a range of effects. Here are some of the notable impacts of solar storms on Earth. Disruption of communication systems. Solar storms can interfere with radio communications, satellite signals, and GPS systems. The charged particles can cause radio blackouts, disrupt satellite communications, and affect the accuracy of GPS navigation, leading to potential disruptions in telecommunications and navigation services. Power grid instabilities. Solar storms can induce geomagnetically induced currents, GICs, in power grids. These currents can overload transformers and other electrical equipment, leading to power outages or even damage to the power infrastructure. In extreme cases, entire regions may experience widespread and prolonged blackouts. Auroral displays. One of the most visually stunning effects of solar storms is the aurora borealis, northern lights, and aurora australis, southern lights. When charged particles from the Sun collide with molecules in Earth's atmosphere, they emit beautiful displays of light in the polar regions. These captivating phenomena are a result of the interaction between the solar storm particles and Earth's magnetic field. Radiation exposure. Solar storms release high-energy particles, including protons and electrons, which can pose risks to astronauts and technology in space. During intense solar events, astronauts on space missions or those aboard the International Space Station, ISS, may need to seek shelter to minimize their exposure to radiation. Additionally, satellites and other spacecraft are vulnerable to the effects of solar storms, including potential damage to sensitive electronics. Impact on Earth's magnetosphere. Solar storms can cause disturbances in Earth's magnetosphere, the region surrounding the planet that is influenced by its magnetic field. This can lead to fluctuations in the magnetosphere, affecting the behavior of charged particles, and potentially causing geomagnetic storms. These storms can induce electrical currents in the ground, affect sensitive electronic equipment, and disturb the operation of geomagnetic observatories. While solar storms can have significant impacts on Earth, modern technology and scientific understanding allow for monitoring and preparation. Space weather forecasting systems provide alerts and warnings about approaching solar storms, giving industries, governments, and individuals the opportunity to take precautionary measures to mitigate potential disruptions and protect critical infrastructure. Here are 20 facts about solar storms and their impacts on Earth, nature, and other planets. Solar storms are caused by eruptions on the Sun's surface, releasing enormous amounts of energy and charged particles into space. The most powerful solar storms are known as coronal mass ejections, CMEs, which can contain billions of tons of matter. Earth's magnetic field protects the planet from the majority of the harmful effects of solar storms by deflecting charged particles. Solar storms can disrupt communication systems on Earth, leading to radio blackouts and interference with satellite communications. GPS systems can experience inaccuracies during solar storms due to disruptions in the signals caused by charged particles. Solar storms can induce geomagnetic storms on Earth, which can cause electrical currents in power grids and potentially lead to power outages. The auroras, northern lights and southern lights, are a direct result of solar storms, as charged particles collide with Earth's atmosphere, producing colorful light displays. Solar storms can increase radiation levels in space, posing risks to astronauts and affecting the operation of satellites and spacecraft. High-energy particles from solar storms can impact Earth's upper atmosphere, leading to increased drag on low Earth orbit satellites and affecting their orbital decay. Solar storms can cause disturbances in Earth's ionosphere, affecting the propagation of radio waves and long-distance communication. Animal navigation systems, such as birds' ability to migrate using Earth's magnetic field, can be influenced by disruptions in the magnetic field during solar storms. Solar storms can trigger enhanced auroras on other planets with magnetic fields, such as Jupiter and Saturn. The surface of Mars is not protected by a global magnetic field like Earth, so solar storms directly impact its thin atmosphere and can cause atmospheric loss over time. Solar storms can affect the atmospheres of gas giants like Jupiter and Saturn, leading to changes in their cloud formations and auroras. Solar storms have been observed to cause disturbances in the magnetospheres of other planets, altering their magnetic field structures. The impact of solar storms on Earth's climate is still being studied, with some researchers suggesting a potential link between solar activity and regional weather patterns. Solar storms have the potential to disrupt satellite-based services such as television, internet, and global navigation systems. Astronauts on spacewalks or outside the protection of Earth's magnetosphere may be at risk of increased radiation exposure during solar storms. Solar storms can generate powerful currents in Earth's magnetosphere, which can induce currents in conductive structures such as pipelines, railways, and long-distance power lines. Continued research and monitoring of solar storms are crucial to improving our understanding of space weather and minimizing potential impacts on Earth and space-based systems. These facts highlight the diverse and significant impacts that solar storms can have on Earth, nature, and other planets, emphasizing the importance of studying and preparing for such space weather events.